morning. So I got some work done again. It's been a really lovely day. It's like when I have to go to do some job, I don't know, it's not as nice. When I wake up like this, I'm like, oh, I gotta do my work and talk to the people. It's not as bad. Okay, so anyway, I had a lovely morning again. All right, so let's talk about what I did today. Okay, so first slide. So the first slide, there's some other large cardinals that might make an appearance. So maybe this is like earlier on in the talk. I have it going, I have like the intro slide, and then I have just a shot of measurable cardinals leading role number 1, shot of super compact cardinals leading role number 2, and then this slide. So this is some other large cardinals, so insert the slide. Other large cardinals that might make an appearance. So like in the theorems we had yesterday, so we have strongly compact, inaccessible. You can see Malo's kind of in love with the inaccessible, so it's like reaching for the inaccessible. Ramsey's got like a lot of color. Oh, I was gonna look up at the definition of ineffable. I forgot, you guys. I don't know. Maybe it's something I can look up real quick. Let me see. I forgot to look that up. I was gonna look it up just for fun. I shouldn't do this right now. Let's try it. Let's try it. No. It says too great to set theory. Let me just see if it's a. Oh, I don't see it's not like a simple definition, at least not for me. Okay, so we'll go back to this. Okay, so some other large cardinals that might make an appearance, but probably just the ones I mentioned in that theorem. This is just for fun. Ineffable is kind of like, and any of the other large cardinals, like, what about us? They want to get involved. They're all connected. They're all friends. And worldly cardinals, maybe I mentioned weakly compact, they all want to get in there. So next slide. So the next slide is about the inevitable degrees of large cardinals. I put the inevitable because maybe that sounds more like philosophical if I say it that way. So like, why are they here? You know, what are they doing? So there's lots of space in between like inaccessible and Malo. The really interesting thing about large cardinals is, and you look at like the history, they kind of like, there's this cardinal, this cardinal, this cardinal. They are, I don't know if they're kind of discovered in order, sort of. But it's very interesting how they all fit together so nicely. And like a Malo cardinal is like the most, is like in my thesis, like the most inaccessible you can be. There's a definition of greatly inaccessible. So it's like a Malo is like the most inaccessible you can be. And they all sort of follow this pattern where the next large cardinal is like a big jump. It's like a big jump, but it's like the most the one below it could be, or something like that. So they somehow fit perfectly together, and then in between there's a lot of space, and almost all the large cardinals have some kind of like availability for degrees. Okay, there's more work. There's lots of work to do. Okay, so and I probably mentioned a few times, like Miha Habich and Victoria Gitman wrote a paper about the degrees of Ramsey cardinals. Okay, so there's lots of degrees. Okay, so this is a picture of an inaccessible degrees. So you have the inaccessible cardinal, just an inaccessible cardinal in the first strip there. And then you could have a limit of inaccessible cardinals. And then you could have each of those cardinals as a limit of inaccessible cardinals. And then you could have each of those cardinals as a limit of inaccessible cardinals. And if you look at the picture, and maybe you want to like, can you zoom in it? I don't think you can zoom in it. Maybe I'll zoom in on the thing. Excuse me, guys. Okay. So you can keep going like that. And it makes this kind of like fractally like picture. Okay, so I really like that picture. Okay, next slide. Okay, so finally, the degrees of inaccessible cardinals. So this is just going to be a part of the slide. I'm going to do, hopefully, maybe we'll do this tomorrow. I want to do like a action shot of what is it like to kill a degree of 1 degree of inaccessible cardinals. So, so yeah, I'd like to, it's a lot, but I'd like to like maybe tomorrow, like make just like a picture that sort of gives you an idea of what goes into killing 1 degree. And actually the Malo cardinals are a lot easier, so maybe we'll do that. The inaccessible cardinals, it's very interesting though, because we have to, we have to adjust the continuum function in order to make some easier calculations. Okay, so it's very interesting. But the degrees of inaccessible cardinals, so this is just to mention, like, this is in my thesis. They were already defined, but I sort of went a little further and gave some words that were necessary. Okay, we could have a whole talk about the degrees of inaccessible cardinals, but I'll just talk a little bit about it, and I want to read a little bit about it. So an uncountable cardinal kappa is inaccessible if it's a regular limit cardinal, if the cofinality of kappa is kappa, and for every beta less than kappa, 2 to the beta is still less than kappa. You can't get to it by power sets. So it's 1 inaccessible if kappa is 1 inaccessible if it's inaccessible in a limit of inaccessible cardinals. And so it's alpha inaccessible if it's inaccessible and it's a limit, and for every beta less than alpha, it's a limit of beta inaccessible cardinals. And so then you sort of hit these roadblocks. And so kappa is kappa inaccessible if we call it hyper inaccessible. Okay, so you sort of need another word, because that way also, like, let's say I have 2 large cardinals, alpha and beta, and I want to say they're both the same type of inaccessible cardinal. But this one over here is alpha inaccessible, and this one over here is beta inaccessible. And it sounds like they're different, but they're both hyper inaccessible. So that's why it's good to have this word, because it sort of relativizes. If your kappa is kappa inaccessible, you know, it's nice to have this word to describe what it's like when you hit that sort of limit. Okay, so hyper inaccessible. So what would come? So also, you can't be kappa plus 1 inaccessible, because you can't be a limit of kappa inaccessible cardinals, because you can't have a cardinal your same size below you. Okay, so what would come next after hyper inaccessible? Then that would be 1 hyper inaccessible. So you're a limit of hyper inaccessibles, but you're not a limit of kappa inaccessibles. You're a limit of cardinals which to themselves they're at that limit. Like, I'm beta and I'm beta inaccessible. Okay, so then there's like this technical definition. A cardinal kappa is alpha hyper to the beta inaccessible if kappa is inaccessible. For every eta less than beta, kappa is kappa hyper to the eta inaccessible, and for all gamma less than alpha, kappa is a limit of gamma hyper to the beta inaccessible cardinals. Okay, but just think, each time you sort of get this roadblock and you have to do something else. Okay, another roadblock we're going to hit is when we get to 1 hyper to the kappa inaccessible. No, you can't be 1 hyper to the kappa inaccessible, because you can't be a limit. Kappa can't be a limit of hyper to the kappa inaccessible. So we have to come up with another word. So the word that I came up with is richly inaccessible. So that's what happens after you don't go to 1 hyper kappa inaccessible. You go to richly inaccessible. Okay, so I'm not going to go into all these, but basically, to get around these sort of like word roadblocks and this, like, you know, I want to say, if kappa is kappa inaccessible and beta is beta inaccessible, somehow we should be able to talk to each other and be like, oh, we're both hyper inaccessible. And okay, and so what we can do is we can use the big omega, big omega, or ord, the symbol for the class of all ordinals. And actually, okay, so we can say, I'll say ord inaccessible is hyper inaccessible, ord squared inaccessible is richly inaccessible. For example, you can mix these up. Ord squared plus ord inaccessible is hyper richly inaccessible. And then they go on. Each time you hit these roadblocks, these powers of big ord or big omega, then you need another word. Okay, so we've got a few words. I've got, and so the words hyper, richly, utterly, and so on mark places in the process of defining degrees of inaccessible cardinals, where we take a diagonal intersection over alpha and ord of a collection of classes. And so each cardinal beta, inaccessible cardinal beta, can be T inaccessible for any meta-ordinal T. And a meta-ordinal is just like Cantor's normal form for ordinals, but you use the big omega instead of the little omega. And you can have any kind of combination. Like here we have ord to the 4th times 5 plus ord plus 3. That would be 3 hyper deeply to the 5th inaccessible. Lots of fun stuff, but we're not going to go into all that because this is about degrees of supercompact cardinals, but you can see where this stuff goes. Okay, so a little bit about degrees of large inaccessible cardinals. I thought this was going to be a shorter one because I was like, oh, taking my time. I got to go. Okay, I'll see you guys tomorrow. Thank you.